Hello everyone, this is Akash. Welcome back to this YouTube channel Nurture with Lecture. In this video, I am going to discuss the methods of differentiation in the differential calculus series. In the differential calculus series, I have already completed the limits, continuity, differentiability. Now it is a time for methods of differentiation. So up to now we have learned how the limit is existing and what is the rules for continuity, differentiability, and when a function is differentiable, it can be differentiated. We can easily differentiable. Basically, when the function is continuous and it can obey the differentiable rules, and when it is differentiability rules are satisfied, now we can differentiate that function. So after differentiating, what are the conditions and what are the different types of functions and how are the procedures we are taking in order to carry out the differentiation process. So in this chapter we are discussing that total. So what are you discussing? Basic formulas. There are so many basic formulas we are discussing in this chapter. And next, what is the algebraic differentiation? How to differentiate when the two functions are in addition or two functions are in multiplication or two functions are in division. So basically we will learn in this. And next, logarithmic differentiation. How, when the log is present, how we have to differentiate. These are all the things I am going to explain in this chapter. But before that, in the change makers batch JEE 2023 series, I already uploaded so many chapters, one shots. Basically, those one shots are made in such a way that every student, even if they are beginner, they can even able to understand. So it is very important to watch those videos also. If you didn't join any my telegram group, it is very important to join the channel's telegram group and also access the handwritten notes as well as the problems given to you to practice. And after practicing, if you have any doubts, please comment. I am able to resolve the doubts for you. So please do that process. If you have any queries or any strategies or anything, if you want, please drop me a message in the comment box. I will take seriously about that and I will do a particular session which will improve your skills. It is very important to do that type of sessions. It is very important. And also I am ready here to guide you and mentor you. So don't think anything like that. If I message you, what will happen? Don't think anything like that. I will bring another sessions. After this change makers batch, there are so many sessions are upcoming. So it is very important to connect with you. If you connect with me, it is way better than I am connecting with you. It is very important. Connecting with you is very difficult. If you connect with me, it is very easy. You can easily connect with me in the comment box. But I cannot connect with you that much. So it is very difficult for me. So if you connect with me and talk with me, it is very important. And when this bonding is continuous, like that continuous functions, we can able to do a great things in life. So I am expecting that from you. If you want anything, please ask in the comment section. I will be able to provide that to you. Now let's discuss the chapter, that is differential calculus, methods of differentiation. These are all the topics I am going to cover, but in every chapter I am writing these things, that is topics to be covered. Why I am writing these things? Because these things give an idea about what are the topics present in the chapter. So if any student watches this slide, that is this board, there are 9 topics which we have to study for differentiation. So they can get an idea. So because of this, I written this. So that's it. Now let's get into this video and discuss each and every topic. The first thing, that is basic formulas. What are the formulas that are present in? I am written clearly in this paper and I taken the PDF of this and I uploaded in the Telegram channel. So anyone didn't join the Telegram group, join the Telegram group. It is very important. You cannot write and waste time. I already written for you. For the sake of yourself, I complete the notes and I am going to upload in the Telegram channel. So anyone didn't join the Telegram group, join the Telegram group. So you can, by seeing this, you can easily learn. Watching the lecture is very important, but making notes this time is very bad because this is a time for revision, not for making notes. Notes making is previous. If you want to make notes, you have to make it from the beginning itself. If you didn't make it, you have to see the PDF, that's it, and you have to revise. You have to keep the rough book and you have to do line by line. It is very important. in methods of differentiation, in basic formulas, first you will already know that you already know what is the differentiation of constant, d by dx of constant. What is the differentiation? 0. You already know first thing. Second thing, x power n. What is the differentiation of x power n? N into x power n minus 1. Second. Next, third, root x. What is the differentiation? 1 by 2 root x. Next, e power x. E power x doesn't change us. E power x, there is a differentiation, e power x, that's it. Next, a power x. What is the differentiation of a power x? A power x log a. Important. Next, sin x. What is the differentiation of sin x? Cos x. And what is the differentiation of cos x? Minus sin x. And what is the differentiation of secant square x? That is tan x. And what is the differentiation of tan x? That equal to secant x tan x. See, if you observe, sin x cos minus cos x. Sin x cos x, this is symbol. If you see sin x cos x minus sin x. Next, tan x. What is tan x? For tan x, what is differentiation? Secant square x. And for secant x, what is the differentiation? For secant x, it is secant x tan x. Secant x tan x. It is important. And next, what is the differentiation for cosecant x? Minus cosecant x cot x. It is a differentiation. And next it is cot x. Cot x is minus cosecant square x. So like this, these are all the formulas. And next, if we see, that is sin inverse x. What is the differentiation of sin inverse x? That is 1 by root of 1 minus x square. It is a differentiation. Next, cos inverse x. Cos inverse x, what is the differentiation? Just we have to keep the minus before this. That is minus 1 by root of 1 minus x square, like this. Sin inverse over, cos inverse x over. Next, tan inverse x. You already know. Tan inverse x is 1 plus 1 by x square. 1 by 1 plus x square. Why I am writing these things? Now you can able to see this board and you can able to fix it in the memory. It is very important. I have no issues. I can easily submit this PDF to Telegram. And you can easily download and access the PDF, but I am writing again. The reason behind this is, after going the next topics, it is important to memorize these topics. For me also, for you also, it is very important. Next, cot inverse x. For cot inverse x, that is minus 1 by 1 plus x square. Next, sec inverse x. Sec inverse x next to cosecant inverse x. That equal to 1 by x root x square minus 1. Here minus 1 by x root x square minus 1. These are all the formulas which came in the methods for differentiation. These are not the methods for differentiation. These are all the useful things for doing the methods of differentiation. These are all the useful things. These are all the things, or the basics for doing the differentiation for any function. So I have written all these things. Now let's get into the second topic. This is the first topic, that is basic concepts, that is basic formulas. Now let's get into the algebra part. What is algebra of differentiation? Algebra of differentiation. What is algebra of differentiation? The meaning of this is, if there is d by dx of f plus or minus g of x function, when there are two functions, whether it is addition or subtraction, what is the algebra we are going to apply in order to solve this differentiation? That is d by dx of f of x plus or minus d by dx of g of x. This is algebra we are using here. Means we are splitting the differentiable function, that is d by dx of f of x plus or minus d by dx of g of x. This is the reason. And next, this is over. And what is next? Plus or minus over, completed. What is about into? That is multiplication f into g into x, that is f of x into g of x. What is the differentiation for this? The differentiation for this is first function into differentiation of second function plus second function into differentiation of first function. This is algebra for multiplication. And next, what is algebra for division? That is, if we take a function u and function v, if we want to differentiate this, what is the thing is, the below, that is denominator, we have to take upward, that is v into u dash, v u dash minus u v dash divided by, this is square, v square. Like this you have to do, t by dx, v into u dash minus u into v dash divided by v square. This is a algebra for differentiation. That is, when it is plus or minus, it will split. When it is into, there will be a formula like this. When there is a division, there is a formula like this. And there is an extended version for this. U into v, this is formula. Suppose if we take u into v as two functions, u into v dash plus v into u dash. This is a formula for two terms. And when there is a three terms, that is u into v into v u into v into w dash plus u into w into v dash plus next v completed, next u, that is v w u dash. These type of extension versions you have to write. This is algebra. And next, suppose d by dx of 2x is present, that is, if there is any constant, suppose 2x square, there is a constant is present, we can able to bring this back, that is 2 into d by dx of x square. What is the differentiation? 2 into 2x, that equal to 4x. This is the answer. And next, what is algebra remaining? That's it. This is algebra, methods of differentiation. This is algebra. And now, basic rule is PBA rule. The meaning of PBA is nothing but P means power, B means base, A means angle. Basically, these are the chain rule. If you observe, suppose there is a function x power 5. First, we have to differentiate power. Power will come down, that is 5 into x, power 5 minus 1, that is 4. Next, that is base, we have to differentiate base, that is for x, that is 1. Okay, and next angle, if angle presents, suppose if we take sine theta whole square, if we take like this, sine square theta, if we want to differentiate, first there will be a power, that is 2, sine theta power 1, and next base, that is sine theta. For sine theta, what is the thing? For sine theta, the differentiation is cos theta. Okay, now angle, that is theta, d theta by dx. This is a procedure we have to follow. This is a rule, that is PBA, means power, base, angle. This is a chain rule. And next, and this is the most important thing. Most important thing is, in differentiation chapter, you should not be in a hurry-burry mode in order to solve these questions. Because in differentiation, it is very important to first simplify. First simplify and then differentiate. First simplify and then differentiate. You already know the meaning of this. Means you have to simplify the given function into a smaller function, and next you have to apply the differentiation process. If it is this much big, you cannot apply the differentiation. If you apply, it will take a long time to complete the procedure. So it is very important. In order to differentiate a function in the JEE Mains examination or any examination, if you want to differentiate a function, first it is mandatory to shorten the function. That is, you have to simplify the function and then you have to differentiate the function. This is the main reason. And next there is a logarithmic differentiation. Logarithmic differentiation. What is meant by logarithmic differentiation? The differentiation of logarithm. That's it. How to do that? Suppose if there is a function like this, f equal to f1x into f2x into f3x, like this there are so many functions. I mean, there is so many in a row. You have to do the differentiation, that is dy by dx you have to do. Then is it possible to do these many things? So it is very important to use a logarithmic use. If you use a logarithmic, what will it turns? Log y equal to log of this all thing. So when it splits, log f1x plus log f12, like this it will come. That's it. And now if we see, and then you can differentiate log on both sides. We are applied, and next we can differentiate. What is the differentiation of log y? What is the differentiation of log y? That is log y differentiation is 1 by y, and next what? Y differentiation dy by dx. 1 by y you can cross multiply and you can write like this. This is a differentiation procedure for logarithmic differentiation. If we got any multiplication functions, so many, you have to apply log on both sides and you have to differentiate individually. It is very easy for doing that. And now let's discuss the derivative for implicit functions. Implicit functions. You already know implicit and explicit, right? If you didn't know, I will explain now. Implicit is nothing but, there are two things, implicit and explicit. If you see those things, that is when you cannot separate the x and y terms in a equation, that is said to be implicit function. And when if you can able to separate the variables in an equation, that is said to be explicit function. So now implicit functions, you have to do what? You have to do the differentiation. For that procedure, it is important that suppose there is a curve like this, x square plus 2xy plus y square. If this is the function and you have to differentiate, there is no way for us to separate x and y terms differently. So it is tedious. Now what we have to do? We have to apply the implicit function differentiation theorem. That is, you have to differentiate this thing first with x. Actually the procedure is like this, that is dy by dx equal to minus dou f by dou x divided by minus dou f by dou y. If you see clearly, if it is reciprocal, you will get this thing. So it is nothing but you have to differentiate this partially. After differentiating, you have to divide. Suppose if we do the differentiation with respect to x, what it will come? 2x plus 2y, 2y, that's it. It is minus. And next, what about dy dou y? That is when we do like this, that is 2x, and next here 2y. That's it. So this is a thing you have to do. And when we cancel, that is minus 1. This is the answer for implicit function. So like this you have to do. That is minus of dou f by, suppose there is a function like this. If it is no, that is if you know that it is implicit, you have to apply it like this. Suppose you are asked to find dy by dx. What you have to find? Dou x by dou y you have to find, and divide by dou y divided by dou x you have to find, and you have to divide by dou f by dou y. And there will be a minus sign, and you have to divide like this. When you divide, it will come like this, divided by dx. This is implicit function differentiability rule, not differentiability. It is differentiation. There's a huge gap between them. And next is derivative of inverse function. Now we are seeing that how to do logarithmic differentiation and implicit functions. Now we are going to discuss how to do differentiation for inverse functions. Inverse functions. And if you see f of x, inverse functions, you already know. Suppose if f is a function, and g is the inverse of f, what we can write? F of g of x is nothing but x na, because f into g means f inverse. F inverse cancel, so you will get x. So like this, f of g of x equal to x. This is the procedure, that is inverse. What is nothing but inverse? When f of g of x is, when we do like this, the inverse and function gets cancelled and you will got x. It is very important. And now we are applying this to the differentiation to this, what will you get? Differentiate both sides, f dash g of x into next power, power, there is no power, you done base, and next you have to do what is the inner sign, you have to differentiate inner, that is g of x, you have to differentiate the g of x which is present inside the f of x, because if we observe clearly, suppose there is a x square function, if you differentiate this, that is 2 into ex, for this you have to differentiate for inside function, that is 1, like this only for f dash into gx you have to multiply g dash x, because this is a differentiation, g dash x is a differentiation for g of x, and when you do this, that is 1, and if you want g dash x, you can easily divide like this. This is a process for finding the derivative for inverse functions. And now there is an important formula just you have to remember, that is cos x base 2, that is x divided by 2 into cos x by 2 square, like that it will go cos x divided by 2 power n. The formula for this cosine series is sin x divided by 2 power n sin x, 2 power n sin x divided by 2 power n. So basically the formula is sin x divided by 2 power n sin x divided by 2 power n. This is sin x divided by 2 power n into sin of x base x by divided by 2 power n. Sin x divided by 2 power n into sin of x by 2 power n. This is a formula. This is a cosine series where n is the number of terms which is starting from 1. So there are total n terms. You can clearly observe here n terms there are there, and the first angle is x by 2 and the last angle is x by 2 power n. Which is the longest angle here? X by 2 is the longest angle because it is a decreasing series here. It is very important. Sin x divided by 2 power n into sin of x by 2 power n. It is a formula for this cosine series. You have to understand. There is no derivation like that. There is nothing like that. You have to just remember the formula. That is cos x by 2 into cos of x by 2 square. Like that, it will, if it will go like this series, you have to apply the formula. That is sin x divided by 2 power n into sin of x by 2 power n. This is a formula. Now there is a start of standard substitution. Standard substitution. The meaning of this is you have to, I already said, in differentiation chapter you have to simplify the function first. So in order to simplify the function, we are using some of the substitution. There are basically 4 substitutions we are using here. Root of a square minus x square, a equal to x equal to a sin theta or a cos theta, and next second root of a square plus x square, x equal to a tan theta, and next third one is root of x square minus a square, that is x equal to a sec theta, and next at the last root of a plus x divided by a minus x. We have to use x equal to a cos theta, or we can use x equal to a cos 2 theta. It is your wish. You can use. Basically, why we are using these things? When we use a sin theta in this place, it will a square minus of a square sin square theta, and when a square is common, 1 minus sin square theta. 1 minus sin square theta is nothing but cos square theta. A square cos square theta. We can get a cos theta. For this a cos theta, you can easily differentiate. But differentiating this root of a square minus b square x square is tedious. If you want to do, that is 2 root a square minus x square into, again for minus x square, that is 2x, and for x 1. So this is the main reason why we are substituting. So for substituting, it is mandatory to see the identities of the trigonometric functions, and according to that you have to differentiate. So it is easy. What you have to do? You have to remember the identities and you have to remove the root. The main purpose of this substitution is removing the root. In order to remove the root, it must be a square, that is a square into cos square theta, that is a is cos theta whole square. Square root will cancel. So this is a reason. So this is a reason for why we are using the standard substitution. Standard substitutions are so many, but this is a common substitutions which we have to use. And next, parametric differentiation. Parametric differentiation. Parametric differentiation is nothing but there will be a parameter which is different from normal differentiation. So we have to implement something in order to do the differentiation. Here, suppose dy by dx. In the previous topic, I already said that dy by dx can also be written as dou y minus dou f by dou x minus dou f by dou y. You already seen. Like this only you have to write again here, but here different. That is, it is not a partial differentiation. Here we have to differentiate with respect to, that is, with respect to the parameters dy by dt divided by dx by dt. That is, dy by dt we have to differentiate with respect to the parameter given like this. I will explain the example for this in the next topic. I will explain. And again, this is a parametric differentiation. Suppose there will be a parameter. Suppose if we take x equal to a cos theta minus t, if there is a parameter t, we have to differentiate with respect to t na? Or suppose if there is no parameter, but x equal to a cos theta, but there is a theta, so we have to differentiate with respect to theta, not with y, not with dy by dx. We have to differentiate with dx by dt, dx by d theta. So in order to differentiate like this, there will be a parameter introduction, that is theta or t. So when it is a parameter t, you will say dy by dt divided by dx by dt. Understand? This is a thing in parametric differentiation. And also d2y by dx square is nothing but d by dx of d by dx. D by dx of dy by dx. It is very important. So many people will confuse in this. And next, differentiation of one function with respect to another function. It is another topic. Differentiation of one function with respect to another function. When you do this differentiation of one function with respect to another function, suppose I am assuming f of x is a function and there is a g of x another function. I want to differentiate f of x with respect to g of x. What can I do? I can differentiate f of x with respect to dx, and I can differentiate g of x with respect to dx, and after that I can complete the answer with f dash x by g dash x. Understand? Means if you want to divide a function with another function with respect to another function, you have to divide individual functions with respective terms. Suppose there is a f of x term, so you have to differentiate with the x dx. So d of f of x divided by dx, d of f of x divided by dx divided by d of g of x divided by dx. So the final answer is you have to differentiate individual functions and you have to divide. That's it. This is called differentiation of one function with respect to another function. Understand? And now, successive differentiation. This is the last topic. Successive differentiation. The meaning of this successive differentiation is, suppose if we take dx by dt, dx by dy, dx by dy, or if we take dy by dx, you can write like this, 1 by dx by dy. It is correct. You can reciprocal it. Or if you writing like this, dx by dy, you can write like this, 1 by dy by dx. You can write this. But what you cannot write, d square x divided by d square y, d square x divided by dy square. If you want to write this, that is d by dy of dx by dy This is, but you cannot reciprocal the things, that is 1 by d square y divided by dx square. You cannot shift like this. It is not legal. It is not legal, it is illegal. And next, if you want d square x divided by dy square, you can write d by dy of dx divided by dy. It is true. Yes, it is true. Like this. And last concept is, if you are doing odd function differentiation, this sign is nothing but differentiation. If you are doing the odd function differentiation, you will get even function. And if you are doing even function differentiation, you will get odd function. Very much important this. It is very important to understand this. Suppose if there is a function that is x cube, what is the differentiation of x cube? 3x square. So odd function you get even function. Suppose if you can get cos x is an even function. If you do the differentiation, minus sin x is an odd function. So if you do even function differentiation, you will get odd function. If you do the odd function differentiation, you will get even function. This is the thing. And the chapter is completed. But there are some questions which we have to discuss in order to gain confidence in this chapter. So now I am going to discuss that thing. That is the first question. Y equal to x power 4 plus x square plus 1 divided by x square plus x plus 1. You have to find dy by dx. This is the first question. I already said, they ask in differentiation, we also know the formulas, all things, but we should not go directly to do the differentiation. What we have to do? We have to first simplify this thing. This x power 4 plus x plus 1, you can write as x square plus x plus 1 into x square minus x plus 1. Is it true? Yes. Then substitute it. What you will get? X square minus x plus 1 divided by x square plus x plus 1. So these two gets cancelled, that is x square minus x plus 1. And when we apply the differentiation dy by dx, you will get for x square 2x, for x minus 1. That's it. 2x minus 1. What they asked is ax plus b. They asked what is a 2, what is b 1 minus 1. So they asked a plus b. So 2 minus 1, that equal to 1. So the answer is 1. This is a question. And next, second question now. The second question is y equal to root of 1 minus cos 2x divided by 1 plus cos 2x. If you observe clearly, root of 1 minus cos 2x we can write as 2 sin square x, and 1 plus cos 2x we can write as 2 cos square x. So it will become tan x. Understand? Tan x. But what tan x? Mod tan x. Because it is under root, you have to add a modulus. But you have to see the sign of this modulus. They are given that the region is pi by 2 to pi. They given the region for differentiation, that is pi by 2 to pi. For pi by 2 to pi, what is the value of tan x? Negative. So you have to open this modulus negative. Understand? Y equal to minus tan x. Now we have to differentiate. Dy by dx equal to minus secant square x. And they asked to keep. What is the value of differentiable total, this value at x equal to pi by 4. If you substitute pi by 4 in this, what you will get? Dy by dx equal to minus secant square pi by 4. It means pi by 4, cos pi by 4 is 1 by root 2. Secant pi by 4 is root 2. Root 2 whole square is 2. So the answer is minus 2. The answer for this is minus 2. Understand? This is a second question. I forgot to explain one thing, that is homogeneous. Homogeneous, what is the differentiation value for homogeneous functions? What is meant by homogeneous? Homogeneous is nothing but homogeneous functions or same power equations. Suppose if we take an example of x power m into y power n equal to x plus y whole power m plus n. If you take this example, the powers are same, that is x by whole power m plus n, you can write. That means there are same powers. So what you can do, the complete answer for this is y by x. You can write directly without even doing differentiation. They asked to find the dy by dx for this function, but you can write directly. What is the reason? Because these are the homogeneous equations. Homogeneous equations is nothing but they have the same powers for all the equations. So if a function is having the same powers for all the types of variables, that is x and y, if they have the same variables, you can write directly as y by x. You can directly write as y by x. This is a reason why the answer is y by x. The third question is completed. Now they asked f of x equal to x cube plus x power 5, x cube plus x power 5, and they asked g is the inverse of, and they said g is the inverse of f of x. What they are expecting? They are asking g dash 2. I already explained. If f is a function and g is the inverse of this function, that is g equal to f inverse, you can write f of g of x equal to x. You can write. Is it correct? Yes. You have to differentiate. I already said. If you apply the differentiation formula, you will get like this. That is 1, and that is g dash of x equal to what? G dash of x equal to 1 divided by f dash g of x. Is it true? Now they are asking g dash 2. That is, we have to keep x value 2. Then what will be the answer? 1 divided by x dash g of 2. Is it okay? G dash 2. 1 by f dash g dash 2. Correct. Now we want g dash 2. So we are keeping this x cube plus x power 5. For this we have to do differentiation, that is 3x square plus 5x power 4. This is differentiation, and inside that we have to keep, what we have to keep? 2. 2 square 4, 4 3 is 12 plus 2 power 4 16, 16 5 is 80, that is 80, 1 by 92. Is it correct? Check one thing. What we done? Wait a second. Sorry, I written wrong here. If f is a function and g is the inverse of f, we have to write by outside, that is f of g of f of x equal to x. It is true now. Means you have to differentiate g dash of f dash x into f dash x equal to 1. So g dash of f of x equal to 1 by f dash x. So we have to keep x value, what? F of x equal to 2 means what we have to keep? This complete f of x value is true, 2. That is, this value is 2. We have to keep 1 plus 1. Is it true? Yes. So we have to keep the x value is 2, that is 1 by f dash 2. We have already done the differentiation. What you got? 3x square plus 5x power 4. What you have to keep? 2 in that. If you keep 2, that is 2 power 4 16, 16 5 is 80, 2 square 4, 4th is 12, that is answer is 1 by 92. Like this you have to do the answer. You have to see what you have to keep outside, what you have to keep inside. Here you are finding the unknown for g dash. So you should not keep inside f. You have to keep outside f. It is important. And the last question is tan inverse root of 1 plus x square minus 1 by x. You have to find dy by dx for this function at x equal to 1. If you observe clearly, there is a root here. When you see the root, you have to think about the substitution. So 1 plus x square, what you can substitute? X equal to tan square theta, you can substitute. X equal to tan square theta, yes. Tan square theta not. X equal to tan theta. Then theta equal to tan inverse x. Is it true? Yes. Then tan inverse, what you get? Secant theta minus 1 divided by tan theta. Is it true? Now 1 by cos theta minus 1 divided by sin theta by cos theta. Cos theta, this cancel. 1 minus cos theta divided by sin theta. This thing you got. 1 minus cos theta divided by sin theta. Tan inverse of 1 minus cos theta by sin theta. What you can write? 1 minus cos theta is nothing but 2 sin square theta by 2. And sin theta 2 sin theta by 2 cos theta by 2. 2 cancel, sin theta cancel. This whole thing is converted into tan theta by 2. So the answer finally is theta by 2. What is theta? Tan inverse x means half tan inverse x. Means half tan inverse x. We have to differentiate this thing. Means half into tan inverse x. What is that differentiation for tan inverse x? 1 plus 1 by 1 plus x square kada. Half into 1 by 1 plus x square. We are finding at 1 x equal to 1. So half into 1 by 1 plus x square means 1 plus 1. That is half into half, that is 1 by 4 answer. So this is a final question, and that's it. The chapter gets completed, and next we are going to discuss the applications of derivative part. So that's it for the video. If anyone didn't join the Telegram group, join the Telegram group and access the handwritten notes as well as the practice the questions which I given to you in the type of Google form. Fill the details and also access the complete information in that. So that's it for the video. Thank you.